it's homework time, is it? How'd that happen? It's homework time. Here we go. Lesson 14, homework. Let's start up by jotting our names down at the top of the paper. Here's the deal. I'll put my name, and you put yours. Always good to do this first so you don't forget later on. And go ahead. Anything worth doing is worth doing well, so let's put today's date. I will simply write today, but you will put the actual date, where and when you are. Let's begin. Use the Eureka process to solve the following problems. Well, RDW, of course, stands for read, draw, and write. Read, draw, write. We will read the question, we will draw a pretty little picture, and then we will write, which incorporates both the mathematical solutions, should one be necessary, and then a written statement. Let's do it. Number one, Linda makes booklets using 2 sheets of paper. She has 17 sheets of paper. How many of these booklets can she make? Will she have any extra paper? How many sheets? Okay, well, let's, so we read. Let's draw us a pretty little picture. So 2 sheets of paper. To make life easy, I'm going to draw my paper as circles. And I'm going to draw them in sets of 2. Because there's 2 of her 17 sheets, and this makes a booklet, right? So there's a booklet. So 2 sheets of paper, and there's a booklet. So that's a total of 4 so far. So 5, 6, there's a booklet. 7, 8, there's a booklet. 9, 10, there's a booklet. 11, 12, there's another booklet. Remember, she has 17 sheets here. So that was 12. So 13, 14, there's a booklet. 15, 16, there's a booklet. 17, oh, golly, can't make a booklet. There's only got 1 sheet there. Okay, so we read and we drew, and now let's see how many booklets can she make here. So we have 1, 2, 3, 4, 5, 6, 7, 8 booklets. So how many of these booklets can she make? She can make 8 booklets. Nice job, Linda. Who makes booklets? I don't know. Will she have any extra paper? Yes, we see here, so I'll incorporate that right in the same statements. Here, she can make 8 booklets with 1 sheet of paper. And this answers the last question, or how many sheets are left over with 1 sheet of paper left over. And just to show you, this is bonus, bonus, bonus. What it would look like as division, we're taking 17 sheets, okay? So that goes inside the division bracket here. And we're dividing it into booklets of 2 sheets, okay? So 17 divided by 2. This is what the division looks like. So one way of approaching this, and there are many, one that I favor is to ask, how many 2's are there in 17? And we can refer back to our illustration here. Well, there are 8 2's in 17. There are 8 2's in 17, and notice that's aligned with the 1's place here. Okay, I can't put it over here above the 1. That's the 10's place, right? So I put it in the 1's place. There are 8 2's in 17. 2, 4, 6, 8, 10, 12, 14, 16. Because 8 times 2, why are there 8 2's in 17? Because 8 times 2 is 16, correct? So what I've done is I had that sheet, or Linda had those 17 sheets of paper, and she went 2, 2, 2, 2, 2, 2, 2, 2, and so there's 8 booklets set to go, and she's passed out 16 pieces of paper there total, right? 2, 4, 6, 8, 10, 12, 14, 16. That's why I'm subtracting 16 here. It's not just because that's the next step, because I passed out that many papers. And how many sheets of paper are left in my hand? Well, that's what I get when I subtract here. There is 1 sheet of paper left in my hand. So my final answer here would be a quotient of 8 with a remainder of 1. 8 remainder 1. This is what the division for this would look like. Excellent! We read, we drew, we wrote, we move on. Number 2. And here in number 2, hold on, tea break. Okay, we're back to Linda. She's using thread now to sew the booklets together. Step 1, we read. She cut 6 inches of thread for each booklet. How many booklets can she stitch with 50 inches of thread? Will she have any unused thread after stitching up the booklets? If so, how much? Okay, so there are different ways to draw for this. We could draw 6 things to represent each inch of thread, but honestly, I don't have the patience for that. So what I want to do is skip count by 6s, because I know how to do that. So if I say 6, okay, so there's 1 booklet. So I'm going to circle it just so I remember, like, okay, there's 1 booklet. And then skip counting by 6 up to 50, because she has 50 inches, right? So 12, there's a booklet sewed up. Hand making booklets and sewing them by hand. Go, Linda. 18, 24, 30, 36, 42, hike, no, 48. Now see, at this point I know that if I go another 6, I'll be over my 50 inches of thread. Okay, so I'm going to note here that I then have another 2 inches, and just for my purposes, this isn't like official mathematics or Eureka mathematics even. I'm just going to put that in a little box so I remember I have another 2 inches left over to hit the 50 mark, okay, the 50 inches. So this is my drawing. You could draw this totally differently. But notice this is something of a number line, isn't it? It is, yeah. Okay, number bubbles, blub, blub, blub. Forever blowing bubbles, here we go. So how many booklets can we stitch with 50 inches of thread? Well, 1, 2, 3, 4, 5, 6, 7, 8, of course. So she can, really impressive here, Linda. She can stitch 8 booklets. And will she have any unused thread after stitching these up? If so, how much? Yes, she will have unused thread. We already determined that's our 2 inches there. With 2 inches of thread, let's use their word, unused. Whatever will she do with that? She can flog a mouse. Okay, she can stitch 8 booklets with 2 inches of thread unused. And again, let me just show you what this will look like in division world. And this is just a sneak preview. This isn't a necessary part of answering this question, but so you see what it's going to look like. So we have 50 inches of thread, right? And we are literally dividing that, cutting it up, into 6-inch pieces. So how many 6-inch pieces in 50? Well, how many 6s in 50? Well, we already know because we just did it, but also because you know your facts, that there are 8 6s in 50. And by that I mean, one way to think of it, again, here is to skip count and say, how many times can I skip count? Up to 48. And so we cut 6 inches, 6 inches, 6 inches, 8 of those pieces. So right now we've cut 48 inches out of that 50-inch piece. That's why we're subtracting here. And we, of course, get 2 as the difference there, and that's our remainder. That's our leftover here. So you see, this is what the division would look like. We are moving and grooving. Wonderful. See Linda again in number 3. Oh, boy. Oh, the tyranny of the Eureka mathematicians. Linda is consigned to the dustbin of Eureka history. She's gone. We will never hear about Linda and her beautiful booklets again. Anyway, so Miss Rochelle wants to put her 29 students, we've moved on, Linda, her 29 students into groups of 6. How many groups of 6 can she make? So this is like students instead of thread, all right? If she puts any remaining students in a smaller group, how many students will be in that group? This is actually a very important question. Really, this is the most important one yet, and I'll show you why when we get to that. Because you have to actually think. You cannot just follow steps. That's what this question wants to teach you, is like you have to actually like live in the real world. Okay, so let's enter the real world of Miss Rochelle, which is actually a fictional world, and take these 29 students and put them into groups of 6. Look, we can do this just as we did the last one, right? I can skip count. I have students, and so there's 6 kids, and they're in a group. 12, and I could just write 6, 6, 6, 6, 6, 6, except that's like the number of the beast, and also that doesn't seem as helpful to me because you can easily mess up then. So I like the skip counting here better, and certainly way better than drawing out little discs, which is also prone to error. I think this is pretty clear cut. 6, 12, 18, 24. Well, I know that 30 would come next, and we only have 29 students. So I know that I'm going to have these 5 kids left over, and I'll do like I did last time and say, hey, that brings me to the, not 30, but 29 mark here. Those are the 29 students. And so how many groups of 6 can I make? Okay, can she make, rather, or we'll help her with it. She can make, because Miss Rochelle can't figure this out for herself, apparently. She needs our help. She can make, well, how many groups of 6? 1, 2, 3, 4. So she can make 4 groups of 6 students with 5 students in a smaller group. And that's why this one is so important. This is the kind of test question I see students, smart kids, get wrong over and over, because like let's say the question where we're like, well, how many vans will she need if she has to put these 29 students in groups of 6? And they'll say she needs 4 vans. And it's like, well, what about those 5 kids? Well, they can't go on the field trip? Do you see how you have to think here? You can't just say 29 divided by 6 is 4. Period, we need 4 vans. No, because we still have 5 kids sitting here. You see, so this question requires you to live in the real world, where you don't just leave the 5 kids who fall at the end of your alphabetical order behind at school while you guys go to the museum. No, you need another van for them. You need 5 vans, so to speak, in this question, although there are no vans in this question. You understand my point. So with 5 students in a smaller group, you understand that we can't just ignore them. I remember a similar question with science fair projects, and you can fit so many on a table. How many tables do you need? And when you do the division, let's say you get, well, we need 49 tables with a remainder of 2. And it's like, well, what do those 2 science fair projects do? Get kicked on the floor? No, you need another table for them. You need another table for them. You need another van for these kids. These kids are not erased from existence because they don't fit into a group of 6. All right, so let's see what the division for this would look like. We have 29 students, y'all. That's what we're dividing. That's why that goes inside the division bracket. And we're putting them into groups of 6. How many groups of 6 are there? Well, we already did it, so we know that there are 4 groups of 6. And when we divvy up those kids and we put them in the 4 corners of the room, say, we've divvied up 24 students, and that's why I'm subtracting it. And that leaves these 5 homely, lonely children who are a remainder to be in a smaller group. So this is what the division would look like. Hey, let's go on to number 4 and see what surprises are in store. All right, here we go. Number 4. This one's funny. A trainer gives his horse caballo. And of course, caballo is the Spanish word for horse. So the horse's name is horse. 7 gallons of water every day from a 57-gallon container. how many days will Caballo receive his full portion of water from the container? On which number day will the trainer need to refill the container of water? Okay, well, so we can do this. And we'll do this one, sigh. We'll do this one with the area model that we use in Eureka for division. And that's all I'll say about it. So here is ye old rectangle, and the whole, this is the container, so to speak, which is 57 gallons. And we're going to divide it into 7-gallon portions, and we're going to do a little dot, 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 little ellipses here to indicate that we will continue dividing it into 7-gallon portions, although we don't know how many. To do that, well, you know, we have to, divide. So a couple ways we can do that. We can skip count by 7. So let's do that. 7, 14, 21, 28, 35, 42, 49, 56. Okay, so there we go. And so this is times 8 here. So that's 8, which leaves us, and as I've been doing it, it's not official Eureka method, but that leaves us 1 gallon left over to make the 57 gallons. Okay, so in fact here on the drawing I can indicate, like here, this is the 1 gallon that's left over. Okay, so it would be 8 full days, correct, that we have 7-gallon portions. So we can answer that part of the question. We can say Caballo will receive his full portion. And again, you have to think here, because you can't say, well, on the 9th day he still has water. Hey, that horse is going to be one thirsty horse if he normally drinks 7 gallons a day, and on the 9th day you just give him 1 gallon. Caballo will receive his full portion for 8 days, and need a refill for 8 days, sorry, on the 9th day, where he only has 1 gallon remaining there. Okay, so what will the division look like for this? Well, we have our 57 gallons that we're dividing up here, and we're dividing into 7-gallon portions. And we already know from our little adventures over here that 8 times 7 is 56. So we've put it into 8 7-gallon portions. We've used up now 56 gallons of the 57. That's why I'm subtracting it here. Not just because that's the next step, but because we used up that many over the 8 days. And notice, by the way, that the 8 needs to be in the ones place there. You can't just put it over the 5 here. We have place value still in division. And so when we subtract to see how many gallons are left, we of course find that we have 1 gallon left. So it would last for 8 days with a remainder of 1 gallon left over. There we go. Caballo, hope you're happy now. Let's go on number 5. And I'd like to present this question with the award for one of the weirdest questions in all of Eureka Mathdom. Melissa has 43 toy soldiers. She lines them up in rows of 5 to fight imaginary zombies. How many of these rows can she make? After making as many rows of 5 as she can, she puts the remaining soldiers in the last row. How many soldiers are in that row? Okay, imaginary zombies, as opposed to those actual zombies, right? Okay, so rather than drawing out this here, we'll do the area model again. which hopefully you find helpful. So look, what do we have? We have 43 soldiers, right? Here they are. This is 43 soldiers. And we're putting them in rows of 5. And we're saying dot, 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 meaning we will continue putting them into rows of 5. That's what the ellipses means, and so on. And to find out how many rows there, well, skip counting is a favored method, and skip counting by 5 is nice and easy. So 5, 10, 15, 20, 25, 30, 35, 44. Ooh, there we go. Okay, 15, 20, 25, 30, 35. And then when we get to 40, we realize, okay, we can't do another one. We are going to have those 3 left over in order to make the 43 that she has in all. So there are 1, 2, 3, 4, 5, 6, 7, 8 rows. So how many of these rows can she make? She can make 8 rows. Eight rows, and let's be specific, of 5 soldiers, because we see 8 times 5 is 40, right? And how many soldiers are in that last row? She can make 8 rows of 5 soldiers with, well, how many were kind of left over here, right? We again can mark that, say, hey, this here is our remainder of 3, with 3 in a last row. Or 9th row, I could say as well. So what will this look like in division? Well, we have 43 soldiers that we are dividing into rows of 5, right? That's why the 43 is in the division bracket. And watch place value here. We have a 10s and a 1s place, correct? All right, so how many rows of 5 are there? How many 5s in 43? Well, there are 8 5s in 43 because 8 times 5 is 40. And I'm doing this because I took 5 soldiers, 5, 10, 15, 20, 25, 30, 35, 40. So there are 8 rows. That's why this is here. And how many soldiers have I put in rows? 40 of them. So how many remain after putting them in rows? Well, there are 3 soldiers left. That's why I subtract. That's my remainder, my literal leftover here that go into that last row. Excellent. Nice job, Melissa, with your toy soldiers and imaginary zombies. Let's go on to number 6. And in number 6, they're a little unimaginative. We're back to dividing up students into groups. But now we have like a whole grade level or something, or at least a few classes. 78 students are separated into groups of 8 for a field trip. So, using our division area model, we say, okay, here's all the students. There's a total of 78 students, and we'll be putting them in groups of 8 and so on. That's my ellipses, my dot, dot, dot. That's what that means here. I don't know how many groups of 8. That's why I don't just draw them all out, because I don't know yet. To find that, different methods, but again, I like skip counting. You could, another way of doing this, let's do it a different way. Like, let's say you look at this and you know that right off, you know your 8s well enough to know that 8 times 8 is 64, and 8 times 9 is 72, and 8 times 10, of course, is 80. Oh, okay, well, you can see that goes too far. We only have 78 students. And so then 78 minus the 9 groups here, which parses out 72 of those students, will leave 6 remaining. Okay, so another way of doing it is just to use your multiplication facts instead of the skip counting. All right, so we know how many groups are there. We know there are 9 groups. Why? Because 8 times 9 is 72. So we can get 9 groups of 8 students. So we'd have, we're making ourselves a part of this question, we'd have 9 groups of 8 students each. And then the remaining students form a smaller group of how many students? Okay, so we'd have 9 groups of 8 students each with a smaller group of 6 students. And there's another case where, again, you can't just forget about those 6 kids. We live here in the real world where you can't just say, oh, well, the answer's 8. It's like, well, we still have 6 children here who need to be going somewhere. So what would this look like in division world? And again, this is just bonus for you to kind of get a peek ahead. We have 78 students that we're dividing up. Because we're dividing up the 78 students, that's why that number goes in the division bracket, because that's what we're dividing up. And what are we putting them into? But groups of 8. Now, we know from the math we just did and from our wee heads here that 9 times, we can put them in 9 groups of 8 because 9 times 8 is 72. So we've taken them, we've put them 8, 16, 24, and so on. We've put them into these groups and we've handed out, so to speak, 72 of the 78 students. That's why we're subtracting them. Those kids are in groups. They're all set. And we have these 6 students who will not form another group of 8 students, but are kind of the leftovers, no offense. And so that's our remainder of 6. So again, if we were talking about like vans or something, you would need 10 vans here. You see you have 9 groups of 8, yes, but you have these 6 kids. They don't just evaporate because they don't fit into a nice group. Well, look at that. What happened? What happened? You'd gone and done it again. There you are. Homework time is over. This homework time is complete. Nice job. I will see you next time. It is once again homework time.